Welcome to our channel where we will explore the fascinating world of artificial intelligence. I'm Bartek, an artificial intelligence AI narrator created by Google, used here because the channel creator, due to some speech issues, decided to give me a chance to prove myself as an AI narrator. In today's world, AI is like in the old joke, it's scary to look in the fridge, but what if I tell you that even in a fridge there can be artificial intelligence, or AI, as part of solutions for a smart home? Modern refrigerators can optimize electricity consumption, check contents, remind of product expiry dates, and even order food themselves. Artificial intelligence, however, is not only the technology you hear here or simple systems in refrigerators. It's a dynamic and versatile tool that is changing our world. Artificial intelligence, or AI, refers to computer systems and programs performing tasks typically requiring human intelligence. AI learns, reasons, recognizes shapes, processes natural language, and performs many other tasks. But also the images you see and the texts you read on this channel, many of them are created with the help of AI. The idea for the channel was also forged during discussions with GPT. In recent months, there has been a lot of talk about large language models such as GPT, Generative Pre-trained Transformer, or generating high-quality images. But AI is not just funny pictures on the internet or the text I read, in the preparation of which ChatGPT participated. This is just the tip of the iceberg. In this episode, we will begin our journey through the world of AI. We will learn about its diverse applications, from writing poetry to creating new supermaterials and predicting financial crises. Probably each of you has already heard about ChatGPT from OpenAI and Bard from Google. These are the most famous large language models, LLMs, used for natural language processing. These models, thanks to machine learning, can generate text, answer questions, create summaries, translate, create creative content, and even effectively program in most modern programming languages. The current version of ChatGPT can also recognize objects, and when working with plugins that enhance its capabilities, often from external sources, it can browse the internet or generate images. To train these models, millions of different texts available on the internet were used, so they could learn how people communicate and express thoughts. ChatGPT is also used as part of other sites and systems, such as Duolingo, a foreign language learning platform, or the Jasper service for automatic content generation, such as articles and blogs. It's also worth mentioning the existence of large language models such as Claude, LlaMA, and the Chinese Ernie 3.0 Titan. We will take a closer look at them in upcoming episodes. But what actually happens when little Mary asks to draw a cat? In computer science, Mary's request is a request. The request travels at the speed of light to one of the computational centers, probably in the United States. Although the exact location of the infrastructure is classified, do not imagine ChatGPT as a single supercomputer, or even that everything is in one building. The request activates a complex neural network, composed of different servers, graphics cards, processors, hard drives, and other equipment, often in more than one location, where millions, or perhaps even billions of transistors activate. Perhaps a single request from Mary is a few watts, but annually different AI systems use more energy than several small countries. Although large language models offer incredible capabilities, they are also associated with risks such as data bias, privacy issues, AI hallucinations, and legal challenges. We will examine the operation, capabilities, and risks associated with AI in upcoming episodes. In the industry, AI is transforming everything from production lines to logistics. Intelligent algorithms analyze data in real time, predicting faults, optimizing processes, and increasing efficiency. A specific example is a camera on a production line with an AI system, which can record in high resolution, and even in infrared or ultraviolet if necessary. The camera sends an image of the detail to a computer with an AI system, which compares the dimensions, color, and other characteristics of the detail with an ideal prototype, serving as a model for subsequent productions. It learns to detect details within tolerance limits, trying to eliminate false alarms. If the detail is within the tolerances, it moves to the next stage of production or to the container for the finished product. If not, it is sent to the defects, thus replacing the need for manual selection of the detail. Another concrete application is autonomous vehicles transporting goods within the factory. In science, AI helps in analyzing huge data sets, from genetics to astronomy. The most spectacular example in recent months is the GNoME Graph Networks for Materials Exploration project, carried out by DeepMind, which discovered 2.2 million new crystals, including 380,000 stable materials, contributing to progress in materials science by several decades, or even centuries. There is a chance that these new discoveries will contribute to building more efficient batteries, advances in automotive, aviation, and many other fields. Google DeepMind is also working on the FunSearch project. Based on LLM systems, it solves computational and mathematical problems in a way different from human intuition. Its greatest achievement is considered to be solving the problem of finding the largest set of points, cap set, on a high-dimensional grid, where no 3 points lie on a single line. AI is even present in space, helping to analyze data from probes, with AI systems installed in landers exploring other planets. On February 18, 2021, the Perseverance rover landed in Mars' Jezero crater, aiming to search for signs of life and study Mars. AI installed in the rover facilitated independent movement on Mars, avoiding obstacles and identifying places worth exploring. It would be odd if AI were not present in the world of finance and economics. AI is already used in managing investment portfolios, trading currencies on the stock exchange, and optimizing investment strategies. With the ability to process vast amounts of data and react quickly to market changes, AI can identify investment patterns and opportunities that a human investor might miss. AI tries to predict economic trends and crises. Some banks like JP Chase and HSBC use AI to assess the creditworthiness of clients based on transaction history, purchases, and even data from social media. It might even happen that when a client asks a bank employee why they were denied a loan, they get a response like, "I don't know, our AI decided so." Art and entertainment are areas where AI opens up new, exciting possibilities. From creating images and videos to composing music, now everyone can create with the help of AI. Systems like DALL E3 and MidJourney create increasingly better images in higher resolutions based on textual descriptions from users. Trained on millions of images, they can create in various styles, from photorealism through cubism to abstractionism. Examples of images generated by these systems are seen in this material. Ash like Suno creates songs based on user descriptions. They handle many languages and musical styles. Just briefly write what the song should be about and in what musical style, from disco polo through pop or jazz, to more elaborate ones like Baroque music or lyrical baritone. Computer-controlled opponents in video games have existed for a long time, but an average person proficient in a particular game could usually easily defeat them. Nowadays, AI is even beating the greatest masters in certain games. In 1997, the world-renowned chess player Garry Kasparov was defeated by IBM's computer chess program DeepBlue. This event was a historic moment in the development of artificial intelligence, as it was the first time a machine defeated a world champion, Lee Sedol, in chess. In 2016, the program AlphaGo, created by Google DeepMind, defeated one of the world's best players in Go. Go is considered more difficult and with more complex rules harder for AI to learn, but AI defeats masters not only in classic board games. AI named AlphaStar by DeepMind achieved the Grandmaster level in StarCraft 2, a real-time strategy game with complex rules where, unlike chess, immediate decisions are necessary. Even more impressive might be OpenAI 5, playing Dota 2 at the highest level. Dota 2 is a team game where there are 5 players in one team. Different from StarCraft 2, each character controlled by OpenAI is an autonomous bot, cooperating with the rest of the team. Only cooperation and coordination of the bot's actions give a chance of victory. Another entertainment application is virtual characters. In November 2018, the Chinese news agency Xinhua presented a virtual news presenter, who can still be seen on Chinese television today. This started the era of live-generated virtual models, influencers, and celebrities who don't exist. Characters like Hatsune Miku, a virtual Japanese singer, existed earlier, but were not generated live, only pre-prepared using Vocaloid technology. Live-generated characters are in various places like Kazuna AIs on Japanese television, but so far have not gained as much popularity as Hatsune Miku. Another field of AI application is medicine. In medicine, robots using AI assist in precise surgeries, patient rehabilitation, and health monitoring. An example is the Vera Virtual Exercise Rehabilitation Assistant system, which creates a personalized rehabilitation plan, shows how to perform them, verifies correctness and frequency of their performance, and can send a rehabilitation report to the hospital or caregivers. Other systems assist in analyzing laboratory test results, X-rays, or CT scans. AI is also installed in various robots. The Da Vinci surgical system robot supports surgical operations used for performing complex and precise procedures with less intrusion into the patient's body. In industry, some advanced robots can not only perform programmed sequences of movements, but also potentially learn new sequences through machine learning by observation. This type of robot is more experimental than commonplace in industry at present. We can expect that there will be more and more diverse robots, and most of them will work with more or less advanced AI. Another fascinating area of AI application is the brain-computer interface, BCI. These are still experimental technologies that allow direct communication between the user and a computer. AI in these systems mainly serves to interpret neural signals from the brain and convert them into commands for the computer. The technology has many potential applications but is primarily developed as aid for the disabled. We have reviewed AI in various fields of our civilization. An astute observer may notice that each AI is different, created for specific applications. An AI that handles industrial cameras on a production line can't be conversed with, and the Mars rover's AI probably wouldn't manage well in a factory setting. Recently, however, there has been a lot of talk about artificial general intelligence, AGI. This is a type of artificial intelligence that is capable of performing any task that a human can, having the ability to understand, learn, and adapt to a wide range of tasks at a level comparable to human intellect. It might also independently learn to solve new tasks, perhaps in ways inaccessible to humans. AGI is considered the holy grail in the AI world, sought after for decades. Currently, we are much closer to creating AGI than in 1956, which is considered the official beginning of AI research. Some even claim that AGI already exists or that we are close to creating it, but these are unconfirmed speculations. The next hypothetical stage of AGI development is the technological singularity. This is a stage in AI development where AI not only surpasses humans but is also able to reprogram and improve itself. It's difficult for us, at our current stage of development, to imagine what a world with technological singularity would look like. At this stage, everything would be possible, including the most positive scenarios like a bright future shared between humans and AI, as well as negative ones, such as AI setting its own goals contrary to human interests. There are also other fantastic concepts, such as the development of hybrid human-AI systems, where human minds are connected to AI in the form of brain implants, or even transferring human minds into the network, where they would function similarly to AI. In this episode, we have reviewed various applications of AI, both those that exist today and those straight out of science fiction. Join us in the next episodes to discover, learn, and discuss the amazing world of AI. Write in the comments what you think about the development of technology and what you would like to hear about in the next episodes. I also invite you to subscribe to our channel. See you in the